So, good day everyone, and today I'm gonna teach you how to solve this problem using time rates, or mostly known as related rates. So, what are related rates problems in calculus? Well, related rates or time rates is a problem in which we know one of the rates of change at the given instant. Let's say x is equals to dx over dt, and we want to find the other rate, which is y is equals to dy over dt at that instant. So it comes from its own word. It solved problems that involves in changes. So I'm gonna flash the steps or rules of related or time rates that should be followed to be solved or to solve this problem. In solving word problems involving with time rates, the following steps that should be followed are this. Draw a diagram if it's applicable. Label all the variables with an appropriate symbol and label constant with their own numerical values. Second, determine which rates are given and which rate you need to find and write down for future references. Third, find an equation or several equations relating the variables defined at step 1. Fourth, differentiate the equation in step 3 with respect to time. And lastly, substitute all given information in the result of step 4 and solve for the unknown rate and insert the appropriate units. So after we've learned the steps how to solve this problem involving with time rates, now let us proceed to solve this problem. So as I said in step 1, draw a diagram if it's applicable or possible and label it. So let me get my ruler. So we are looking for a shape of a cone, and as we all know, cone, let's label it by step 1. Oh, okay. Step 1. And the cone shape will be look like this. I'm so sorry for the drawing if it's not that beautiful, but it's just an illustration. So let us proceed by labeling it, and as we said in this problem, a tank of a water shape of a cone is leaking water at a constant rate of 2 cubic feet per hour, and the base radius of the tank is 5 feet and the height of the tank is 14 feet. I'm so sorry if I don't read the problem first, but I will continue. At what rate is the depth of the water in the water tank changing when the depth of the water is 6 feet? At what rate is the radius of the top of the water in the tank changing when the depth of the water is 6 feet? So let us label it. So I'm so sorry for the interruption, but the recorder of the video has been low battery, so I charge it. So let us proceed by labeling it, and it is 5 feet radius base. That means this will be our radius, and it will be 5. It is only a radius, that means it is, this will be 5, and this whole height of the tank will be 14, and this part have the height that we are looking for. So as this is just an representation or image or illustration to make it more understandable, and this is the radius. So that is the step 1. Now we can proceed to step 2, and step 2 is determine the rates that is given and which rate is need to be found. So as I analyze the problem, we can find, yeah, step 2. So as I analyze the problem, we are solving for we are solving for dH over dt. For we have given a dv dt, and that is what are trying to solve. And now we can proceed to step 3. Step 3. So what is step 3? Step 3 is find an equation or several equation that is applicable to our problem. And as we can see in this image or this illustration, that it is a cone shape and it has a water inside, and we are trying to solve the volume of this illustration or this problem. So that will be V is equals to pi r squared h over 3. So this is the finding volume for a cone, and it has a different formula for volume in different problems or different image, if it's cone shape or cylindrical shape or anything else. But now let us focus in this problem. So this problem or this equation will be V is equals to 1/3 pi r squared. So if you are questioning me why, wait, there's missing h. So this will be our equation, and if you are confused how I get this, I try to separate the h to get our equation, to get and to solve this problem. So with that said, we can solve this by v is equals to 1/3 pi, and I'm gonna solve this first. So we are given by r is over h is equals to 5/14. So this is it. And to get the r, to solve this, r squared, we need to r is equals to 5/14 h. You can see here, and we can substitute it here. So I will put a parenthesis to separate it. 5/14 h, don't forget the h, squared, and don't forget the h here also. So this is half of the part of step 3. So let us proceed. V is equals to 1/3 times 25/196 pi h cube. So how did we get this? Well, we simply solve this part first, the 5/14h, and distribute the squared. So we can multiply it, and using the FOIL method, we can get this. After that, we're done. We can proceed now to step 4, which is step 4 is differentiate the equation respectively to time. And are you seeing it? Okay. And step 4 will be dv over dt is equals to here 25/196 pi h squared times h squared times, this is times, dh over dt. So here we can substitute the given because we find the equation and differentiate it respectively to time. So we can proceed to step 5. So in step 5, we can proceed to step 5, but before that, I forgot to put the dv dt given here. Dv dt is equals to 2. So here, dv dt is equals to 2. And the h is will equal to 6 feet, or to 6. And now we are complete. We can substitute here. Wait, I will put the step 4 here. 25/196 pi times height squared th over dt. So now we can substitute and solve it. So dv dt, as I said, as I put now, we will substitute it here by 2. And it will be negative Why? Because we can see, and we will base on this image, that it is leaking 4 to cubic feet per hour. So as it leaks, it will lose and it will be a negative value. So with that all said, we can solve it by putting and bringing down the given, and this will be pi times h squared, and h is equals to 6, so that means it will be 6 squared dh dt, dh over dt. And now we will finish it by solving. Negative 2 is equals to 196 over 25. Oh wait, it will be times. Sorry, my bad. 25 times 1 over pi. We will put a imaginary 1 over top. And 1 over 36 times again is equals to dh dt, to make the dh dt alone. And with that said, it will equal to negative 98 all over 225 pi feet per hour. And it will be dh over dt. So you can see it, right? And that's how we solve this problem. So dh dt is equals to negative 98 over 225 pi feet per hour. So that's how we solve this part, this condition. Up till here. And I will put it as a and we will try to solve the B. Oh, wait. Our magical mirror is moved. Okay. And now we can here. So we're looking here for what trait is the radius of the top of the water. And we are given the depth. The depth of the water is 6 feet. So we will solve it. So as I said earlier, r is equals to 5 over 14 based on the image or the illustration in step 1, and it will result to, we are solving for dr over dt. Why? Because we're looking for what rate of the radius of the top of the water. So it will be equal to 5 over 14 times dh over dt. And we solve the dh dt already, so we can substitute it. So 5 over 14 times negative 98 over 225 pi, it will equal to negative 7 over 45 pi feet per r. So this is the answer for our problem here. So that's how we solve this problem. This is the first part. The answer is dh dt is equals to negative 98 over 225 pi feet per hour. And this is the answer for the second part in the second condition, or second condition, that will be dr dt. Wait, I'm gonna put it. Dr dt is equals to negative 7 over 45 pi feet per hour. And that's how we solve the time rates in this problem. Thank you for watching.